In this video, we'll be going through a variety of derivative rule problems. Let's dive in. The first thing you should recognize about this problem is that it's going to require the quotient rule. The quotient rule deals with problems when you're taking the derivative of the form some function f divided by some function g. If you have a function in this format, which we do, the derivative of f divided by g follows the pattern f prime g minus f g prime over g squared. So we're calling f the top, so just copying it here separately in my preparation for using the quotient rule. F prime would therefore be 6 plus 2x using the power rule. G is x squared minus 3, the bottom. G prime therefore is 2x, also using the power rule. I have all four of my ingredients, so all I got to do is put them into the recipe. So the derivative of the original function is f prime g minus f g prime. So f prime is 6 plus 2x. G is x squared minus 3, f prime g minus f, which is this, times g prime, which is 2x. Can't quite fit it in. Over the original bottom squared, over g squared. Not g prime, but just g. Whatever the bottom was, keep it there and square it. Let's see if we can simplify this. If I double distribute on the top, sometimes known as foiling, for that first term I get 6x squared minus 18 plus 2x cubed minus 6x, and that's going to be subtracted, and I'll try to keep my parentheses here consistent at least. If I distribute the 2x, I would have 12x squared minus 6x plus 2x cubed over the same bottom as before. So I'm not even going to write that. I'm just going to say see above. Okay, simplifying further, same bottom as before. I have 6x squared minus 18 plus 2x cubed minus 6x. Go and distribute that negative, which came from the quotient rule. That would give us negative 12x squared plus 6x minus 2x cubed. So now if I combine my like terms, this is my final step here, so I'm going to bring the bottom back just so my answer is complete. 6x squared, any other x squared terms? Here's one. 6 minus 12 is negative 6x squared. Any constants? Negative 18. I believe that's the only constant. You can see that I'm putting this in descending order, which is a stylistic choice. I have 2x cubed minus 2x cubed, so that's actually going to cancel. That's cute. I also have minus 6x and plus 6x, which cancels. So I believe that takes care of all of my terms, which means this should be the result. Next example has 2x to the fourth times tangent of x. F times g. So right away you know this is going to be an example of what's called the product rule. Our problem is in the form f times g. Derivatives of this type follow this pattern. The derivative of a function times another function is the derivative of the first times the second plus the first times the derivative of the second, f prime g plus f g prime. Once again, let me list out my ingredients. Color coding here a little bit. F we're calling 2x to the fourth. F prime we're calling, well, it's the derivative of that, so it would be 8x to the third using the power rule. G we have defined as the second half of the function, or tan of x. G prime, therefore, if I know my trig derivatives, which I should, the derivative of tangent is secant squared of x. Therefore, the derivative of y, the original function, dy dx, is f prime g plus f times g prime. Sometimes there are opportunities to simplify this, but here this is good enough. There's our answer. The key part is to recognize why the product rule is being applied, and then, of course, to be able to do it. Here we have negative 3 times cosecant of 3x to the 5th power. Some may argue, understandably so, that this might be a product rule problem as well, because isn't that f and isn't this g? And I suppose it could be. However, if you were to list it out this way, what you end up with is f being negative 3. The derivative of a constant is 0, which means part of your product rule is going to fall apart anyway. So instead, which again, I could look at it that way, but to make it a little bit easier, I'm just going to treat that constant as a constant and have it as part of my answer. It's just a coefficient. So I'm going to focus on the derivative of this. The derivative of cosecant, you should know, you should have it memorized, is negative, so the 3 is multiplied. So the derivative of cosecant, which is the outer function here, and that's a giveaway that this is going to be the chain rule. The derivative of the red portion is negative cosecant times cotangent of whatever the original function, the inside function was. So the inside function, again, is a chain rule, some chain rule vocabulary. Did not budget my space here very well. Let me rectify that. The derivative of the inside part can now be attached onto the end. Using the chain rule, the derivative of the inside would be 15x squared. Oops, that's not right. 15x to the 4th. So simplifying this a little bit, I have a couple of things multiplied here. A negative 3, use a different color, a negative 3 times a negative, that's positive 3, times this business times 15x to the 4th. So let me combine these non-trig terms. So it'd be negative 3 times negative is positive 3 times 15, which is 45x to the 4th. And then my trig terms I can bring down, cosecant 3x to the 5th, cotangent 3x to the 5th. And there's our answer. This one says y equals 5 cotangent x squared plus sine of 2x. This actually is 2 problems in one. Here's a problem, and there's a problem. We're just going to add the derivatives together. So once again, the 5 is a constant, so it's just going to multiply by whatever the derivative of cotangent is. So the derivative of y. The derivative of cotangent is negative cosecant squared. So that's the derivative of this portion here. The inside part is x squared, so that's going to stay as is. Inside part means chain rule, so times the derivative of the inside part, which is 2x. Plus, dealing with the other part of the problem, which I haven't really looked at until now, the derivative of sine of something. Sine of something, the inside part, once again, chain rule. So sine of something in red is cosine of something. In this case, that something happens to be 2x times the derivative of that inside part, which is 2. Simplifying here where I can, I have 5 times a negative 1, which is negative 5, times 2x, which is negative 10x, cosecant squared x squared. That's this first business here. And then not much to simplify there. We typically put the constant out front as a coefficient. And here would be our answer. Moving right along. No more trig. What we have here is a classic chain rule problem, where f, the outer function, is this, and the inner function I'll leave there in blue. So the derivative of, so this is the chain rule, the derivative of f of g of x. the derivative of this composite function is the derivative of the outside part in red, leaving the inside part as it is, times the derivative of the inside part. We call that the chain. So the derivative of the outside part at the inside times the derivative of the inside. So the derivative of y, the overall problem here, let's take the derivative of the outside, which is in red, so that would be 4 times 8, 32, inside part to the 7th power. Let's leave the inside part as it is, multiplied by the derivative of the inside part. So that would be 2x minus 3. That's the chain. Let's see if I can simplify this a little bit. I have 32 times this times this. Let's multiply these together to combine them. That will give me 64x minus whatever 32 times 3 is. I should know that, but it's 96. Times this guy, and there's our answer. Painless. Trig again. And what on earth is this? Tangent squared, or trig function to a power of something like that, is equivalent. So I'm not doing any kind of calculus or anything like that. I'm just writing this in a more recognizable format. Is this. To avoid ambiguity, we put the exponent on the trig portion. So this is a double chain problem. Here's why. There's the outermost layer. Here's the middle layer. And here's our long johns underneath. So peeling away the onion, if I mix my metaphors there, take the derivative of the outermost, the red. That's 2 to the first power. 2x to the first power, so to speak. Well, here x is a function, so I'm going to leave that as it is. Next layer is the blue. What's the derivative of tan? The derivative of tan is secant squared. Leave the innermost part as it is, times the derivative of that innermost part, which is 8. This gives me a simplified answer of 16 tangent 8x secant squared 8x. Logarithms. Okay. The rules to remember here are these. The derivative of ln of x is beautiful. It's 1 over x. The derivative of log base some number a to the x is, well, not as pretty. It's 1 over x times ln of a. So here's our rules we have to know. Note that it's not log base a of just x. It almost never is. Got to use the chain rule with all of these rules. But notice the similarities here. This is an example of this rule. The 2 is a constant multiple, so 2 times whatever, okay. Log base 4 of blank. Doing the chain rule coloring here. Log base 4 of the blue stuff. According to this, the derivative is 1 over whatever we're logging, I feel like a lumberjack, times ln of the base. But 9x squared minus 3. Chain rule, we've got to multiply by the derivative of the inside part, which is 9x squared minus 3's derivative is 18x. Can we simplify this? Yes, we can. 2 times 1 times 18x on the top there is 36x On the bottom, I have 9x squared minus 3 times ln of 4. Not so bad. Not a log, but an exponentiation problem. So two things to remember. One's a no-brainer. Derivative of e to the x is itself. Beautiful. The derivative of some number to the x is itself times ln of the base. Okay. Once again, the 8 is a constant multiple. 3e to the 4x is going to be, let's see, 3e to the 4x, or e to the 4x, so it would be 3 to the 4x times ln of 3, but this is just for x. If that's something else, it is, multiply by its derivative, whoops, lost a 3 there, multiply by its derivative, which is 4. So, notice the original function appears in the answer, ln of 3, times the derivative of the exponent, which is 4. I have 3 constants here. They're here, here, and here. Those are all numbers. 8, duh, 4, duh, ln of 3. Less obvious, but it's some constant decimal. So I'm going to combine those all together. That's 32 ln of 3. And then this is the variable part, the exponential part. That'd be times 3 to the 4x. Typically, we could write this as ln of 3 to the 32nd power times 3 to the 4x. The reason we do this is a single number, and it's usually best to have a single coefficient out there for exponentials. But again, the boxed-in answer is perfectly fine. Last one, I think. Yes. Okay, e to the something. So this is our opportunity to use this beautiful rule. Y prime is itself times the derivative of the exponent, which is negative 2x. These are on the same level, so negative 18x e to the 6 minus x squared. Hope this helps.